Alrighty, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Goo. Today, notes number 4/5, because this is gonna, after we finish these, we'll be able to do the rest of the homework. So, today, exactly as the title says, we're gonna be graphing and transforming the natural, let me close the door though. We're going to be graphing and transforming the natural exponential function. All right, it's called the natural exponential function because it is an exponential function, but we're using e, which is the natural base, right? So, before we start though, quick refresh. What is e round to two decimals? Like, if you gave me two decimal spots, what would e be? 2.72, very good. So, basically then, we're just doing an exponential function, right, where the base is 2.72, right? That's pretty much what we're doing. All right, so let's graph. First, we're going to do the most basic one, the parent function. All right, so we're going to start doing the basic parent function. Remember, the parent function of any exponential function is just a base raised to x. Okay, so in this case, f of x equals e to the x. This will be our parent function. All right, so we're just going to graph f of x equals e to the x. So we're going to start with the 5 points just to be very accurate at the beginning. Then later we'll just use 3 points. How do I get my y values though? Equals e to the x, right? It's the parent function. Y is always your parent function. So my x values will be -2, -1, 0, 1, and 2. So let's see. Where should I start here then? What's the easiest one to find? 0, right? Because it's going to be e to the 0, which is equal to what? 1. That's right. 1. So there it is. 1. What about when I plug in 1? What do I get if I rounded it? 2.72, right? And if I plug in 2, this is where you need your calculators. What is e squared going to be about? (7.3) if we round it correctly. 39. All right, good. So we got our positive points. Let's go in the other direction. E to the -1. Once again, probably have to use your calculators for this one. E to the -1. What? E is about 2.72, right? So if we raise it to the first, it's just 2.72. Raise it first, yeah. E to the -1? What is it? To the -1 is 0.37? That's right. And let's just go one more. E to the -2 would be what? 0.14, that's right. 0.14. There it is. Okay, so let's graph this basic parent function here. So we got -2, 0.1, -1, 0.37. It's not going to be perfectly accurate. 0, 1, 1, 2.72, and 2, 7.39. So it's going to look something like this. This is your basic f of x equals e to the x. All right, so real quick though, first we got to do the asymptote. What is the asymptote on this graph? That's right, it's y equals 0. What is the domain? That's right. The domain is always the same for all exponential functions. Remember that. And what is the range? Y is greater than 0. Right, where did you get the 0 from? The asymptote? And how did you know that it's greater than and not less than? Yeah, because your graph is above the asymptote. And that is the parent function. Very good. Okay, so we're going to do 2 examples of transformations. I'm not going to go super in depth because we've already done this pretty much, right? So we're just going to do 2 examples real quick with transformations. So the first example is going to be f of x equals e to the x minus 1 plus 2. E to the x minus 1 plus 2. Anytime you have a function with transformations, the very first thing you want to do is list the transformations. So what are my two transformations here? Right 1 and up 2. Very good. Okay, so I'm going to show you something a little different than what we're used to here. But first of all, let's get our parent function points. This time we'll just use 3 points, okay? So -1, 0, and 1. How do I get my y values? E to the x, right? It's always the parent function, which is just your base raised to the x. So what are my 3 y values then?
0.37.
Right?
1.
Right?
And 2.72.
Right. Okay, so I'm going to show you a different way to graph this. Some people, you know, if you're really good at doing the table, right, and manipulating table values, and you're good at adding and subtracting all that stuff, then sure you can do this, right? But the way I like to actually do it, I've never used a table. That's something new that I even, learned this year. What I do is actually just go by a visual. So what I'm going to do is I'm going to take these table values. This is the original, right? I'm going to graph these originals first. So -1.37 is right here, 0, 1, and 2, or 1, 2.72. So these are my originals, right? Let me zoom it in. These points are from my original parent function graph, right? But is that what I'm graphing here? No, I'm trying to graph the transformed function. But all I need to do is, from these points, I just take these points and move them all right 1, up 2, and that's my transformed graph, is it not? So watch this. If I take this top point right here, move it to the right 1, up 2, boom, right here. This next point that's on 0, 1, right 1, up 2, it's right here. Next point that's right here. Move to the right 1, up 2, and it's right there. And so that is my graph, just right there. You just got to be careful that you do not cross the asymptote when you're drawing the graph. Look at this. I'm not going to cross. That's actually terrible. I'm not going to cross that line right there. But you see this? I was able to get my complete transformed graph without even touching the table. All I did was move my points right 1 and up 2. Okay, so what is my asymptote on this graph? Asymptote is y equals 2, that's right. Remember, for exponentials, it's always y equals. Y equals is a horizontal line. One quick way you can remember that y equals is horizontal is because, look at your asymptote, right? Which axis is it going through? The y, so it's y equals. Okay, what is the domain? That's right. Ronnie with 1 on the scoreboard. All right. And what's the range? Y is greater than 2. So once again, where did you get the 2 from? Asymptote. How did you know it's greater than? Right, because your graph is above the asymptote. Very good. And we're going to do one last example with transformations. So this last example is going to be, not yet, that's tomorrow. F of x equals -2 e to the x. So first things first, we want to list the transformations. What are the transformations here? Reflect over x, that's right, because the negative sign is on the very front, in front of the e. And what does the 2 tell us? Let me get this out of the way here. Yeah, it's a vertical stretch by. That's correct. Vertical stretch by 2. Okay. So once again, we're going to get those parent function points, right? So x, how do I find the y values? E to the x, right? So -1, 0, 1. What are my y values? Right? 1. There we go. Okay. So I'm going to show you my way again. Once again, if you like using the table method, right, and changing the table values, you can do that. But I'm not going to do that. Giving you another tool that you could possibly use. Some people like this way better. So I'm going to graph the originals. Which way do you like better? Oh, the one I'm doing now? Yeah, so watch this then. Even though these transformations are a little different, they're a little weird, right? You can still do the same thing. You just got to understand what it's saying. So these are my original points. My first transformation is reflect over x, right? But what does reflect mean? If you're reflecting over the x, you're like doing it upside down. You're making a mirror image across the x. So if I look at those points and I'm mirroring it across the x, watch this. I don't even know what these numbers are, but look at this. That's where the points end up after the reflection, because that's a mirror, is it not? So I was able to get that, no table needed, right? I literally just flipped it over. I just drew it like a mirror image across the x-axis. But is that it? No, what else do we need to do? Vertical stretch by 2. Now, how do you show that without using a table? All that means is, look at how far each point is from the x-axis. You see that? To the distance? And just double that. So watch this. On my point over here, look at the distance right here. It's like this, right? I'm supposed to double it because it's a vertical stretch by 2. So I'm just going to add another one of these bars. Ends up about here. That's what you're doing. That's what vertical stretch by 2 means. You're doubling the distance it is from the x-axis. Right? So this one's very obvious because it's exactly on -1. Where should it end up? -2. This one's really tiny though, but if you double the distance here, it'd be somewhere around right there. So once I erase this, look, this is what it looks like. Oh, wait a second. It's going flying. So then when you connect your graph, make sure, once again, you don't cross the asymptote. Something like this. So this is a very intuitive way of graphing without messing with your table values. When you mess with the table values first, that's very mathy, very arithmetic, but this is the visual way of what's actually happening on your graph. And like I said, you can use either way, whichever way you would like to use. All right, so what is the asymptote on this one? Y equals 0, right. Remember, there's no up or down movement in the transformations, right? So it stays at y equals 0. Asymptote. What's the domain? Right, negative infinity to positive infinity. And what about the range? Y is less than 0. Why did you say less than this time? Under the asymptote. Very good usage of vocabulary words, Ronnie. All right. All right. So we're going to turn to the backside now. You might notice there's a little empty space here because we're going to write a little note here. What's the difference between e raised to the negative, in parentheses, x plus 2, and e raised to the negative x plus 2 with no parentheses? We're going to take a look at this. These are not the same graph, okay? They're different. They are both doing transformations, but they're different in one way. Let's take a look at it. Right, but let's see how it actually changes the graph. So if we look at e to the negative x plus 2 with the parentheses, right? Can you tell me the two transformations here? What's the negative sign? Reflect over y. Reflect over x would have to be in front of the e. Yeah, so this is reflect over y, that's right. But then what does this plus 2 on the inside of the parentheses tell me? Left 2, that's right. So, that's the basic, transformation rules. You guys got that one. But now let's take a look at the other case. E raised to the negative x plus 2 with no parentheses. Can you tell me the two transformations here? What is the negative sign here? You guys should know this one. What is the negative sign? What does a negative tell you? Reflecting. So is that reflecting over anything different here? Not really. Still reflect over y. Remember, reflect over x, the negative sign has to be where? in front of the E. That's right.
Oh, so basically like one saying up to, another one saying up to.
Not quite. If it was up to, it would have to be a big up to it here at the end. So what do you, this one is right to, right. This is right to. It's a little confusing, right? Because both of them say plus 2, right? But that's why you don't want to write your equations like this with no parentheses, because that just makes everything look confusing. Now, why is this one to the right too? Did you just guess that one because that was one of the choices left?
No, because you're adding like a negative to the x, I mean to the 2. Right?
What do you mean?
No, because
I think because you're thinking about the other way, right? Okay, so why is it to the right too? Because look, in our original rules, how would I end up with something like this? Because remember, we're supposed to have parentheses, right? So how could I end up with something like this? That means my original must have been negative x minus 2, right? Because if I distribute the negative sign to both, yeah. If I distribute the negative to both, what do I end up with? Negative x plus 2, right? And so, but look at our original. If I ask you, what are the transformations here? Which way is it moving? With the negative 2 right there. To the right 2, right? And so that's why the second one is to the right 2. But this is why you always write your movements inside parentheses so you don't confuse yourself, okay? But yeah, that is the difference between these two equations. All right, now let's write some transformations then. So pretty much we're transforming y equals e to the x. And yeah, you just got to tell me what I need to write. I'm going to call on you guys for this one. Y equals e to the x. First of all, it says shifted 5 units up. So Holly, do you know how I could show that it's being shifted 5 units up?
Plus 5.
Where?
Big plus 5.
Big plus 5. That's right. Big plus 5 at the end. Okay, good. That's the shift. That's the shifted up 5. Good. And what about the reflected across the x-axis? Where? Before the e. Very good. Nice. Good.
Yeah, I played. You said after. No, after the equals.
What? Who says that?
He was like after. He was like after the e. Cosine. All right, and now for the second one. This one's a little more challenging, maybe. Y equals e to the x. First, reflected across the y-axis. How do you show reflected over the y-axis? Like before the x, right? Yeah, so the negative sign in front of the x. But now we have to show that it's also shifted left 7 units. In parentheses what? Plus 7, that's right. Nice. Good. Don't forget the parentheses. All right, let's go to the next one. This one is vertically stretched by 3. How do I show vertically stretched by 3? Not minus 3. This is a vertical stretch.
Oh, so 3E.
There, 3e. That's right. The 3 goes in front of the e. It's multiplying. Okay, then shifted right 6 units. How do I show that?
Plus 6. No, minus 6.
No, plus 6 without.
Where?
Plus 6 without parentheses.
No, we cannot do that.
That would be left 6. Wouldn't that be left?
Right, it's minus 6. Minus 6, as usual, it's going to the right 6 units.
If you put plus 6, it's left 6.
Yeah, it's left 6, right. That's only different when you have like a in the parentheses and a negative sign on the outside. So, but, right, to be safe, you can always just write parentheses like this, and then, you know, there will be no confusion.
And then big one.
Up one, what did you say? A big one. Okay. The big plus 1 at the end right there. All right, last one. Y equals e to the x. Now, how do I show that it's reflected over the x-axis again?
Negative in front of the E.
Before the E.
Before the E.
Right, negative before the. Okay, you're. All right. How do you show that it's being horizontally stretched by a factor of 3?
Put a 3 in front of the X.
A 3 in front of the x? Not quite.
After the E.
It is in front of the x, but it is 1/3, as Aiden said. It's 1/3. Remember, horizontal, you use the reciprocal of whatever is actually happening right there. And so this is e. All right. So that's the end of transformation. So up until now, right, all this stuff is stuff you've already seen before. But now, this part right here, example 2, This is a part that a lot of us struggled on the test. Either I'll say 50% of everyone who took the test either left it blank or completely wrote the wrong answer. And then the other half, there's like 20% who almost got it right, messed up the last part. And then there's the other 30 who actually got it right. So let's see how we do this. First of all, guys, cross out this y equals e to the x right here. I'm gonna write the examples here. Okay, so use your calculators to analyze the minimum and maximum values of the function on the given intervals. Okay, this was on the test, right? And a lot of people did not know what you should be doing. So I'm going to give you 3 different examples. The first one's going to be y equals e to the x. Yeah. Josh. Okay, y equals e to the x on the interval of 0 to 6. Now, that's one way to show you an interval. Another way to show you an interval, which is what they showed you on the test, was 0 less than or equal to x less than or equal to 6. Both of these say the same thing, interval from 0 to 6. You're limiting where you're looking. So you're looking for the minimum and maximum of your graph on this interval. So now the wrong answer here would be the minimum 0 and the maximum is 6, okay? Some people just put that, 0 and 6, right? Why is that the wrong answer? Because 0 and 6 are your x values. 0 and 6 are your x values, but what is minimum and maximum looking for?
Y.
The y values, right? So how am I going to find my minimum and maximum? Right, all you have to do is plug in these numbers in for x. That's right. So which one's going to be my minimum, though, when I plug in which one? 0. And which one's going to be the maximum? So let's find it. So to find the minimum, I'm just going to put in e to the 0, which is equal to what? 1, so that's the minimum. To find the maximum, I'm going to put e to the
6.
and put that in the calculator and tell me what you get. So it rounds off to about 403.43. Good. Okay, so that one's pretty simple. Now, let's take a look at another example then. Y equals e to the x plus 1. This is another mistake that some people made. These are the people who almost got it right and then messed up at the very end. Because, let me give you the interval is going to be -1 to 2. Some people, they would put in the -1 or 2, right? But at the very end, they forgot to add 1. Because the equation is e to the x plus 1, right? So you got to account for that. So, what am I going to plug in to find the minimum? Right. And to find the maximum, I would plug in? Right, so yeah, that's right. So to find the minimum, you would go e to the -1 plus 1. So what is e to the -1? 0.3, yeah, this is on the front page, yeah, 37. So don't forget the plus 1, so my final answer should be?
1.37.
Right, 1.37 is the minimum. Alright, so to find the, what's my equation going to be to find the maximum? E squared plus 1? What is e squared?
E squared
Yeah.
is
7.39 plus 1, so 8.39 will be your maximum, right? Do not forget about the plus 1 at the end, because that is what the original equation said, is e to the x plus 1. Alright, so let's do one last example then. Wow, how big are you writing? Come on now. Yeah. Y equals e to the x minus 2. Yeah. Y equals e to the x minus 2. This time the interval is going to be from -1/2 to 3. Okay, so can you tell me how I would find the minimum here?
minimum would be -1/2.
Right, but how would I find it?
0.5. E 2.5.
E to the is negative 1/2.
Negative power.
Negative 0.5. Is that it?
Minus 2.
Minus 2. Alright, so what is e to the negative 0.5?
That will be 0.6.
0.61, right. Then we got to bring down the minus 2. So what is my final answer here?
Negative 2.6.
Not quite. Negative 1.39, that's right. And this is the minimum.
Oh, this is a positive.
Yeah, it's positive 0.61. And how do I find the maximum on this interval? E cubed, right? Minus 2, right. We plugged in the 3 for x. So e cubed minus 2. What is e cubed? 20.08. That is correct. So 20.08 minus 2, which is about what? 18.08, and that would be the maximum. That is right. So this is how you find the minimum and maximum over an interval. And that ends the note. So now we should be able to finish the rest of the homework that we started yesterday. So until next time, see you in the next one. Peace.